Hey everybody, this is Larry. It's December 26th, that is in New York. I'm going to do a bonus random question that I haven't done before. I feel like it's been a while. Let's do a medium one, just to kind of get it into it. Let's go, 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 go. Okay, so I haven't done this one. It is apparently a premium question, so let's get started. You don't have, I mean, obviously, hit the like button, hit the subscribe button, join me on Discord. But also, if you don't have premium, then let's just do it together. 24 is 17, closest fair integer. You're given a positive integer n, we call an integer k fair if the number of even digits is k in k is equal to the number of odd digits in it. Okay, return the smallest fair integer that is greater than or equal to n. So first of all, we know that it has to have even number of digits, right? Because the number of even digits is equal to odd. So for stuff like, if it has odd digits, you could, I mean, I haven't thought about it yet, but, or I haven't thought it all the way through yet, but if you have a linear thing, or if you're doing like a scan, that you always want to just skip ahead, right? So now you could skip 600. And of course, the next observation right after that is noting that, 1 is a good answer. Sorry, not 1 is not a good answer. I was thinking about something else for some reason, but yeah, this is a good answer. This is a good answer. Is it? This is a good answer, right? So these are going to be basically the upper bound of what you want to do, right? Okay. Yeah, so if, what is the bounds on 9? Okay, 10 to the 9. So then basically at the very worst, you have something like this, as, maybe one more, but you get the idea, right? Okay. And then the question is, how do we do it, right? So, let's see. Let's play around with a random number. These examples are kind of terrible, so not useful. So let's, at least for me, because like I said, if you have odd digits, then you can just go to any of these, and that's a very easy solution. Let's say you have even digits, like, I don't know, I'm just banging on the keyboard, and here this has 2 even, 4 odds, right? Then that means that we have to convert one of the odds to even. And in this case, it's just very easy, right? Because we just add by 1. I'm trying to think about what is the worst case of, like, if we want to increment by 1, what is the worst case there, right? I mean, other than going to the next digit. Let's say we have, I don't know, 7777, and then, or even just all 7s, right? Then what happens? Because that is, we have 6 odd digits, and we want to get to 3 odd, 3 even, right? So do we just, I guess we have, I'm trying to, because basically, for example, you could just say 888, right? So that's an obvious answer, but it's not the smallest answer, right? Because the next answer is actually 800. And then you think about, like, okay, what about the opposite, right? Meaning you have, like, say 888, and then you have 777, and then you, I guess 88888, and you want, then you have 911 or something, maybe, right? That would be the next answer. Or maybe not even, right? No, 8, no, you need to, so you have to change this one, and then you have to change these 2. I mean, I feel like I see a heuristic, but it's still, because basically what you always want to do is just move stuff from the back. But, and also you're not trying to minimize, you're not trying to minimize the number of digit changes, right? And what I mean by that is that, for example, let's say maybe even one of these is good, say 777, I don't know, 870. So we need to convert this to even, or maybe even I guess this is an example, right? Like we want to convert this to 8 and 0, and it's or maybe even this is 8, say, right? Even though we could, so the next smallest number, if this is the input, the next smallest number isn't an 8 here, even though we only change one digit, it's actually 800, right? Okay. I think I know how to do this, and it's just brute force. Because I think now that I'm kind of playing around these property, you can say that, let's say we have the biggest number, a 10-digit number, which is actually not even possible, because it has to be less than 9 digits or something. Or, well, I mean, except for 10 to the 9th, everything has to be 9 digits, right? So then, and we already have these answers. So but let's say we have 10 digits, right? I think this even works anyway. If we have a 10-digit number, I don't know, it doesn't even matter what it is. We can get the answer by changing 5 digits no matter what it is, right? Yeah, because it doesn't matter whether we need 3 evens, 3 odds, or whatever it is on the right side, depending on what's on the left side. We can just do it by incrementing because of that, and because there's only 100,000 cases, and you check each one in log base 10 time, that should be good enough. So this is a very this is one of those problems that is I feel like if you're really smart, you get it really quickly because you figure out all the things that I was talking about very quickly. Or if you're really YOLO and you really don't care, you also get this very quickly because you didn't worry about it with timeout. We'll see if that's true, but okay, let's try that though. I think, but if you want the proof to why it works, I think this is a good enough proof, because no matter what these first 5 digits is, you can change the last 5 digits. And this is only with 10 digits, right? If there's only 8, which I think is the actual bound, you get it from 10,000 iteration at most anyway, or something like this. So, and yeah. So yeah, okay. So then I still want to round up just because I feel like that will save us some time anyway. Yeah, so that if okay, so length is equal to this thing, say, right? If length is equal to odd, then we return something like this, right? So if as 1 digit goes to 0, if it's 2, it goes to 1. So yeah, something like that, right? And then otherwise, if as even digit, we just keep on incrementing, right? So if good of n, or maybe while not good of n, we increment, and then we just return n. And good is just we convert x to a thing. Oh, we don't even have to, right? We just go I don't know, delta 0, 0 while x is greater than 0. Okay. If x mod 2 is 0, 0, delta 1, else delta minus 1, and then x, oh, whoops. Oh yeah, 10, right? And then we just return where the delta is 0 to 0. I mean, of course, this is good for these cases, but let's try some of the stuff that we were talking about. Where did I go? I mean, okay, fine. You know, like 9 digits, but also something like 777. Maybe 2 more digits. And then I don't know, something like that. It should be okay. So it looks good. Running time seems respectable. Let's give it a submit. If it times out, I'll be really sad. After all the things that I was talking about. Maybe it will time out. Is it this case that's timing out? I'm actually a little bit surprised, not gonna lie, because I feel like, oh, I guess this is one case that I didn't factor in. But I thought it should still be. Oh, because I see. I missed a case. I did miss one case. Even though, I mean, my idea is mostly right, but the case that I missed is if it goes from 8 digits to 9 digits, or like a even number of digits to odd number of digits, so then you have to go back up to one of these things. What's the best way to do it? So basically, if we after increments, if it is like I mean I could obviously do this again, but I feel like that's kind of expensive, and I'm trying to think whether that's a better there's a better way of doing it. But it should be okay after we fix it. All right, whatever. Let's just I guess we could do a cheap test first, which is if and odd digits of n return. I guess now I should put this on the thing. This is called upper bound, maybe. Right. Yeah, and then we return upper of something like that, right? This may, I mean, this will be slow, but it should be fast enough. Probably could actually do this in a better way, but oh well. Something like that. Okay, so now this is fast enough again. Unless I have a typo, this should be okay. Yeah, I didn't really consider that case. So I did miss that case. Yeah, I mean, I just didn't put it together in a good way. But yeah. Overall, like I said, I mean, so you I guess they do force you in that sense, because I was wrong about. I mean, I did the case analysis, but I missed the one case. You cannot naively do a while loop, but it is very close to that. So yeah. So what is the time complexity here? This is exponential the way that we did it, because the size of the input is the number of bits, and of course we basically is like you know, like if we have 10 bits, we do 10 to the 10 to the 10 to the n over 2, right? Not this n, but like n is an input n, like 10 to the n over 2, which is 10 to the n, which is 2 to the n, in complexity. So this is exponential time, right? But you know, given that the constraints are small enough, it should be good. But we have to be a little bit careful. How is the running time again? Oh, it's still really fast. I worried about optimizing it for no reason, I guess. I mean, you could have also, we could have done a little bit smarter here, but I'm just lazy. You can also do logarithmic math, but I mean, I'm fine here for now. Cool. That's all I have for this one. Let me know what you think. Yeah, I'll see you soon. Stay good, stay healthy, to good mental health. Goodbye and take care. Doo-doo.